In this example, we're performing another hypothesis test with a proportion. According to NPR in 2016, 32.1% of adults aged 18 to 34 lived at home with their parents. Sociologists recently surveyed 500 people in the age range from 18 to 34 and found that 143 of them did. At a significance level of alpha equals 0.05, do we think the proportion has changed? Again, here I'm always going to use the p-value method when I can. So let's state our null and alternative hypotheses. So the null hypothesis in this case would be using the data from the past that the true proportion of adults who lived at home was 32.1%. In other words, p is equal to 0.321. And according to some survey, well, what do we think about this data now? So in this recent survey, they want us to know if this is any different than it was before. So we're just looking at if this is not the same as it used to be. So is p not equal to 0.321? And before we compute our test statistic, I'm going to gather my sample data, which was the information that we had here. And so in our sample, we had 500 people surveyed, and we found that 143 of them still lived at home. So with that, we can get our point estimate, which is 143 over 500. So let's see what we get as a decimal there. Something around 0.286. So this certainly appears different than the claim in the null hypothesis. But let's see how unlikely this sample would be if we suppose that null hypothesis to be true. So let's now compute our test statistic, where we're using, this is our value for p hat, minus the claimed value in our null hypothesis, and then divided by the standard deviation, square root of pq over n. And let's see, so p hat, which was 0.286, minus p, which was 0.321, and square root of pq over n. So pq was 0.321. For q, we'll do 1 minus 0.321, which is 0.679. Over the square root of n, which was 500, our sample size of 500. And let's punch this into our calculator and see what we get. Again, I got to be careful when I'm entering this stuff into my calculator not to forget that we need to group those two terms in the numerator. Okay, and you should get a value of negative 1.67. And I'll go out to 3 decimals here. Now with that, our goal would be to compute the p-value, but here I'll remind you that because it's not equal to, we're going to do the two-tail p-value. So negative 1.67 was our test statistic. So we'll actually have a negative and a positive version here because we're going to do the two-tail p-value. But really what I'm going to do is just find this area and then times it by 2. So here our p-value will be 2 times the area below negative 1.676. Because by the symmetry of it, we know that this area would be the same as this area over here. So we can just simply multiply that area by 2. So we'll do 2 times, in this case, the probability that z is less than negative 1.676, where we're going to use the normal CDF on our calculator. In this case, negative 1e99 for the lower value, negative 1.676 for the upper value, 0 and 1 for the mean and standard deviation. Okay, and when I compute the normal CDF, I get 0.0468, but I don't want to forget I need to multiply that by 2, which gives me a value of about 0.0937. Okay. Now let's compare this with the significance level that we had. In this case, the p-value that we get, how's that comparing with the significance level? Well, in this case, the significance level was 0.05, and the p-value that we got was 0.09. So we see that we actually get a value for a p-value that's greater than our significance level. So that means we're going to fail to reject. We're not going to reject our null hypothesis. And the way we want to draw our conclusion here is that since we failed to reject, we would say that there's not enough evidence to support the null hypothesis, but moreover to support the claim that p is not equal to 0.321. So in other words, we get something of an inconclusive result here. Because even though we were able to reject the null, even though we were able to say that we couldn't accept the alternative hypothesis, we are not necessarily able to accept the null hypothesis either.